This is the Spikenzie Labs calculator kit, which came from Canada, Montreal, and it's basically an old school style calculator built in an acrylic case with 7-segment red LCDs, and you can see the parts list here, and it runs on an 80MEGA328, which is pre-programmed. Has a bunch of momentary buttons for the keys, a couple of 0.1 microfarad caps, handful of resistors, all 10k, and it's powered by a single CR2032 battery. And it's got all the housing and assembly parts for the case, which, as I say, is clear acrylic plastic. So the finished item will look like that, and I'll put a link in the description, so if you're interested in this kit, you can go and get one for yourself. The kit, unfortunately, cost quite a lot of money, really. It was about $50, but what I didn't realise was the amount of customs charge that I was going to have to pay here in the UK, which was about £14 sterling, and that made it rather an expensive kit. Had I known that, I possibly wouldn't have bothered. But there we go, I've got it now, and so let's have a look at this thing. These are all the buttons for the calculator. We have the 7-segment LCD modules, all fairly well potted, as you can see. Pretty typical, nothing particularly special there. That's the 80MEGA328 chip, as you can just see inside there, with some resistors and the 2 caps. The momentary switches for the calculator keys, the battery cell holder, and some screws to hold the casings together, and the PCB, which come on to a minute, and this little lot here, covered in blue protective plastic, is the case that the finished item will be placed into. So it's nicely put together. It's reasonably good quality. The PCB, as you can see here, is got good screen printing on it, explaining everything that's is going on and where everything belongs. You can see that's where the main processor goes, 10k resistors, obviously the LCDs go along there. On the back, nothing but of Spikenzie branding on the top, and that's pretty much it. Fairly basic kit, nothing too elaborate, and very simple for somebody like me who's not an electronics expert by any means, to do a little bit of soldering. It's all through hole components, there's no SMD on this, so it's an easy build, and well, let's see how it comes out. The calculator kit actually doesn't come with the instructions, although, let's be honest, there's not an awful lot here to work out how to build it. Perhaps when it comes to building the case up and positioning the buttons, the instructions are going to be useful, but Spikenzie supply a very detailed and very high quality, I have to say, PDF file on their website, which gives you all the instructions and step-by-step process and how to build this kit. So it's worth going through that just to make sure you don't make any mistakes on the way. So I've got that in front of me here. I won't show it on camera. You can have a look at it through the link that I put up there, and review it for yourself. But as I say, it's relatively straightforward, so let's follow the process. The first thing I'm going to do, actually, they do tell you to put the battery holder in first, but I'm going to be awkward and I'm going to do the 10k resistors. So these are the 10k resistors, and the thing about them is that the pins, the legs on them, are very, very thick, heavy metal, and I don't think I've ever come across resistors of that quality before. Rather like them. Anyway, they will be fitted into these slots here, neatly marked 10K. So I'll go ahead and I'll solder those in. Okay, so that's the 6 resistors installed. The next thing to do is the 2.1 microfarad caps, which will be installed in these 2 locations here. Okay, so that's the 2 caps now installed. And the next thing to do is to install the buttons for the momentary switching, which is these little buttons here, of which there are 17 to go into these slots. So I shall install all of those. Okay, so that's all the switches installed. Each switch has 4 pins that required soldering. As you can see, a fair bit of soldering needed, but that went okay. And there was even one spare left over, which is a good thing. So I guess if you damage one during installation, you've got a spare. At least I think it's a spare. We'll see. But you can see the 4 legs there. 4 of those for each switch. Okay. Okay, well the next thing to do is to install the LED modules. And Spikenzie tell you to check either side of the LEDs to make sure there is no residual epoxy, and if there is, to clean them off, and also to make sure the legs are nice and straight. Well, I have to notice that the ones I've got, the legs are, on quite a few of them, in pretty bad shape. Look at this. I'm not entirely sure that's a good thing. This is the condition that they arrived in. I don't know what the normal conditions would be, but for a brand new LED module such as this, but there you go, that one's bent all over the place. So I don't know why they're in that condition, but that's the way they arrived at my doorstep. That one's okay. So the next thing I'm going to do is just spend a little bit of time looking at the legs of each of these LED modules and make sure they're nice and straight, and obviously straighten out the ones that aren't. So that's what I shall do next. Okay, to install the LEDs, it's important that they're flush next to each other and nicely spaced out. So Spigen have supplied this plastic jig, I guess, which you place on top of the board like that, and you can see they line up with the pinholes. And then the idea would be that you place each LED into those pinholes one by one to make it nice and even. Obviously this is, well, I'm guessing this is a laser cut piece of plastic, and you can see here the bits of plastic that were left in the holes here, and I have to say some of them were quite difficult to get out, so it took a bit of force to remove them, so they weren't fully cut. So go easy when you take those bits of plastic out, because you do risk breaking this. Although if you do break it, it's not the end of the world, because once the LEDs are installed on top of the plastic like that, this piece won't be visible, so it won't be too bad. But just be aware of that when you're actually using this spacer. So as I say, what happens is you put the spacer on top of the places where the LED segments go, place the LEDs in, and they'll go that way with the dot to the bottom right hand corner like that, and you'll do that for all LEDs across the board, and then obviously solder them from behind. So I shall get on and do that. Okay, well I've now got the LED modules lined up, and you can see they're sat on the spacer there. Really the condition of the pins, the fact that they were so bent on a lot of them, made this a real struggle, and I had to spend a fair bit of time lining everything up to make sure it was absolutely bang on. And they're all sitting in there quite neatly now, and now I just need to solder them. What I shall do is just solder one pin of each module and then check that they are properly seated in their positions, and if they're not, then just put a bit of heat to the one soldered pin. That will push it down into place, and then it should be perfectly lined for the rest of the pins to be soldered. So let's see how that turns out. Okay, so that's the LED modules all soldered in, legs trimmed. Went pretty smoothly, so no great problems there. The next stage is to install the brains, the ATmega 328 processor. I'll focus it in there a bit so you can have a look. Doesn't want to. There you go. Which is soldered directly to the board. The thing you have to do with all ICs like this, of course, is to bend the legs into the body of the IC a bit, because they are flared out, so you need to kind of make them straighter. So I shall do that and solder it in directly to the board at this location, and we'll see how that goes. Okay, so that's the ATmega offered into the board, and you can see that it's lined up with the notch on the IC to the notch shown on the silkscreen of where the ATmega sits. So all I need to do now is solder that into the board. Okay, so that's the ATmega soldered in finally, and the last thing I have to do is install the battery holder for the CR2032 button cell battery, which goes here. So that'll be soldered on there. In fact, it's the other way around, I believe, like that, and it'll be soldered with the two tabs at either side of it, just there, and the same on the other side, just there. So let's do that. Okay, so that's the battery holder now soldered in, and with that the construction of the whole board is now pretty much complete. You'll see at the top here there are pinouts for ground, data, transmit, receive, a 5-volt supply, and ground. They, I'm guessing, will be connections for those of you who are into programming Arduinos and such like. I guess you could play about with it, but the ATmega 328 rather is programmed already, so there's nothing for me at least to do with those particular pins. So the next thing I think is to build up the case. Okay, now we've got the main board built, it's time to have a look at the case. Clear plastic acrylic, I think it is, and you can see it's covered in blue plastic to protect it. So all of that plastic's got to be peeled off. It's important to make sure that these remain clean, because you leave fingerprints and dirt and dust on it after you've assembled it, then it's going to look horrible. So it's just as well to have a cleaning cloth handy, something like that, just to clean the parts as you go along. So next thing I'm going to do is remove all this blue plastic. Okay, so that's all the plastic parts cut out, rather the blue plastic removed. I noticed on a couple of parts, this one in particular, where the holes hadn't been completely cleared of plastic from manufacture, which meant the plastic had to be removed. And on a piece like this, which is fairly delicate, it took quite some force to remove the plastic from that hole there. So if you get one, just be aware of that, and just go careful. So now it's time to actually follow the instructions in the PDF file that Spikenzie provide and put the case together. Each of the keys of the calculator also have these button bases, which are to help stop any binding of the buttons when they're pressed, and you can see that these are covered with blue plastic as well, so better start peeling those off as well. Okay, the first stage of building the case was to take 3 of the plastic case parts, large parts. There's a solid plastic rear, and then there is a thinner, rather a thicker inner piece in which you place those plastic squares that I showed you earlier that I hadn't taken the blue plastic covering off. And then on top of that is another similar size one, but with a slightly smaller hole, so that means that the plastic spaces or button covers are sandwiched in between these 3 layers. And then they're held together temporarily with the screws. And the next stage will be to stick the relevant buttons onto the right or the correct keyhole. So let's do that next. To make things easier, if you have the PCB next to the case as you're sorting out the buttons, the PCB obviously shows you the position of each of the keys, of the relevant keys, so you know that you're putting them in the right slots. So we'll get on and place all the keys in their correct locations. So just to show you the installation of one of the keys, you can see that on the back of them, this is the clear key, you can see on the back of them there is some paper which we need to peel off, like so, and place it in the correct slot. You can see it's stuck onto the piece of square plastic that's sandwiched between those plates. And there's a slight rubber feel to these keys as well, which hopefully will give it a nice tactile feedback. So what I'll do is I will install all the other keys in the rest of these holes. And that's all the buttons installed. Okay, so I finished building the case. Everything's sandwiched together. The PCB's installed. As I say, the instructions, the very clear instructions provided by Spikenzie on how to put the case together are very, very good, so no problems there. Awfully fiddly, probably one of the most fiddly things I've done for a while, but you can see just there the plastic back that is on the button, and the button just sticks directly to it, and that's what kind of makes it fiddly, that you have to sandwich all these things together to make sure they work. But the end result is that the buttons are nice and clicky and tactile, and they feel very nice. You can see I've also removed the black plastic, the paper protective covering for the buttons, and you're left with these glossy black numbers, which actually look very nice. Probably don't show up brilliantly on the camera, but it looks very good. And I guess the thing we need to do now is to see if we can get it working. So for that we need the battery, which is a CR2032, again provided by Spikenzie as part of the whole kit, and that slides in the back here like so, and we have life of some sort. And there we go. So let me just switch some of the lights off so you can see it better. It looks quite white, the LED, but it is actually a very dark red and very clear. So let's just try 2 times 2 equals 4. Excellent. So there we go. It's all working. Let's see it all lit up. Clear that away. Perhaps light up all the LEDs there. And it's functioning very nicely indeed. Okay, let's just pop the lights back on again, take one more look at it. And there we have it, the Spikenzie Labs calculator in its clear acrylic case. Nice kit, very good quality. The instructions are absolutely excellent. They clearly put some thought into this kit, and as I say, the quality is very good. So I'm going to thoroughly enjoy using this. Was it worth the money? You know, I don't know is the answer to that. I think what upset me the most was the fact that I had to pay a fair bit of money to pay for customs charges, which kind of took the shine off of it. But you know, I think all in all, having completed it, having seen the final product, I'm very happy with it, and have no regrets at all. And I think I'm going to get a lot of use out of this calculator. One final touch is that they also supply these little rubber feet, which is probably no bad thing, because let's be honest, that back cover is going to get scratched up fairly quickly, I would have thought. So sticking those rubber feet on is no bad idea. So with that, I'll say thank you very much for watching. I hope you enjoyed the video. I'll pop a link in the description to Spikenzie Labs if you want to get one of these calculators yourself. And if you do, I hope you enjoy it, and catch you again. Cheers for now.